So yes, I am Mandi Walls. I work for Chef. I've been with Chef a long time, actually. So this hasn't always been the main part of my job, but it is what I do now. If you'd like to get in touch with me at any time, you can certainly email me, reach out on any social media except Snapchat. Too old for Snapchat, but I'm LNXCHK pretty much everywhere else. In addition to myself, we have an internal community lead for InSpec. He is based in the Washington, D.C. area in the U.S. His name's Adam Leff, and if you have additional InSpec things to talk about, you can certainly reach out to him as well. So if you're not familiar with Chef, is anybody not familiar with Chef? We've had a few questions over the past couple of days of who we are and what we do. So Chef's been around almost 10 years. We started out as a configuration management, system automation kind of company doing, started mostly for Linux initially, but also for Windows and later AIX and other commercial Unixes. We are based in Seattle in the United States, and we have additional offices in San Francisco, London, and an engineering office in Berlin. So what we have been doing over the past 6-7 years, working with our customers and our community, is basically learning how we can help them and how our product helps them, but also where other gaps are in the tooling systems, the ecosystems that they work with. So as we moved into doing more enterprise companies over the past several years, we've really started to learn about how those companies operate and what they're thinking about current technology trends and where technology is leading their businesses in all kinds of parts of the market. So really what we're learning, and I think what other management and executives are learning, is that slowly, in some cases, every business is becoming largely a software-driven business, a technology-driven business. And this is a big departure from 10, 11 years ago or so when the Harvard Business Review said, outsource everything. Don't do technology, it's a waste of your money. So that reversal has certainly come around. Last year at our conference, the CIO of Alaska Airlines did a keynote address for us, and he basically said that they're basically a software company with airplanes. So while they spend an awful lot of money, the capital investment on buying these large flying tubes, as well as the politics involved with getting berths at US airports and all the other strange regulatory things that go into it, the largest part of driving their success, driving their customer satisfaction is coming to them through software and technology. And it was a pretty powerful message. It was a great talk. He's an excellent speaker. And if you're interested in that sort of digital transformation, it's a good one to look up. It's on our YouTube channel. So with that, what we've sort of branched out from just doing systems automation is also looking across the rest of the ecosystem and playing around with sort of other parts of the tool set. So of course we have Chef, and it's very much a mature product, has been around for a long time. Last year we released Habitat, and we did a workshop on it here the other day. It's a much more immature project. It's for immutable architectures and things like that, so experimenting with that side of things. But I want to talk about InSpec, which is sort of in the middle. It was started by another company called VolcanoSec. They were based in Berlin. There's a couple of guys that had been working with some of the big companies in the German market, and we basically bought them a couple of years ago and are bringing their stuff in line with our workflows and ecosystems and all of those kinds of things. So it's an interesting tool to look at for the things that it does. So our motivation for things like InSpec and other automation tools are like looking at what the workflow looks like. And we talk about continuous delivery, and we have all these other buzzwords, and the DevOps versus maybe DevSecOps or DevOpsSec or however you want to call it, and integrating all these other requirements and things that people need. So as we move our applications through our workflow, we have things like dev and QA and staging. And then for some of our larger customers, we were seeing this security review pop up. And you'd have to like call down to the dungeon and ask the necromancer if they would come up and do a security review on your new platform. And sometimes it was fine, and other times it was basically a big old stop. And all flow of product ideas and features and innovations would come to a grinding halt on this one bottleneck for security review. And sometimes people would get unjammed by turning it off completely, just getting rid of that entire step. And what we see from that is then you end up with post-production scanning, and that doesn't help either, right? It doesn't lead to this sort of continuously changing environment and helping people stay on top of their security and compliance requirements on a regular basis. So looking at other things that come up in the market and the way security and compliance and this sort of drive towards making all of our things be in line with safety, right, in a risk reduction in certain ways. There's lots of stories, horror stories, about how things go badly for people who don't do sort of basic activities. And looking at things like this story, where you have like a server install results in a 2.14 million HIPAA breach fine. So HIPAA is a set of health insurance, patient advocacy roles in the United States. It's privacy and that sort of thing. And the drill down was they left the default settings in place on a new server. And we're like, oh, we know configuration management. We know about default settings. Like, all these things fit in our workflow. What do we need in the language to address these kinds of things? In addition, even more recently, WannaCry keeps popping up. This was from the other day, 6/21, and of course there's been more stuff this week, but Honda thought they had patched their stuff and things keep popping back up. So we need a tool that will help us integrate all of these things with a full workflow. So looking at Test Kitchen with the InSpec tool, the way that we wanted to say, so Test Kitchen, by the way, is a tool that sort of lives in the Chef ecosystem and helps you do sort of continuous fast feedback for testing and infrastructure. So it's one of those things that helps you stay on top of stuff on a regular basis. And we're like, well, if you want to stay on top of your security and compliance constraints, it should be part of this workflow as well. So one of the first integrations for this InSpec tool that we're going to talk about was an integration with Test Kitchen. And that's what that ends up looking like for something like WannaCry. And we can run this all the time. We end up getting our successes and failures. So we have all of these things that are essentially technology problems, but when they get out into the world and they get out into the news, especially, anything that hits the main news for people who, like your dentist is reading this in the newspaper, like, how do we explain to them what are we doing with our security in order to sort of bring all these things sort of in line? So we end up with looking at it as a communications problem because we have three groups of people who have different parts of the workflow that they care about, that they're responsible for, and different parts of that workflow that sort of emerge in certain places. So as we were talking to some of our customers, we've got things like our compliance officer, and they have these like documents that are usually hard copy. They might walk around with a binder, right? So years ago, I worked for a contractor in the U.S. government, and those folks would come into our data center, and they'd have like written pages and flip in a pen, and it was just ridiculous. And then you have folks like your security folks who are probably specialists in a particular operating system or a particular platform, and they have a set of tools specialized for those places. Probably Shell or something highly portable on Linux on that side. And finally, we have these new DevOps people popping up, and they've got a whole arms race for all kinds of tools and DevOps. So on our side, those tend to be in Ruby. So we have places where we have these required inputs into the life cycle of the system, and what we wanted was a place to sort of combine everybody's requirements into something that all three of these groups could ingest, could add to, could think about in a rational way. All right? So that ended up being our InSpec project. So at the baseline, InSpec is human-readable specification language. If you come from a Ruby ecosystem background, the spec part tips you off. That's what it's going to look like. It has facilities for creating, sharing, and reusing profiles, which was something that we found was a constraint in a lot of places where different business units might be using very similar profiles and very similar risk aversion tactics, but not sharing their stuff across. And making these things very shareable, very portable was super important. There's also an extensible language underneath, Ruby, so you can build your own rules for your internally built applications and systems. So when we look at some of the resources that are built in, there's a lot of stuff there, but there's always more stuff that could be included that you guys know more about than our engineering team does. Additionally, there's command line tools. You can plug it into existing workflows. You can use it on your desktop or build servers or any of those kinds of things, just to make sure that it's always in your workflow. And like I said earlier, it integrates with our Test Kitchen project for fast feedback for local testing by your developers. So in theory, nothing should sneak in as people are working on new projects. Maybe they're writing new daemons and you're not sure that the firewalls should be open or the ports that they're using and those kinds of things. So in the whole part of the workflow. So as a basic example, something like SSH. And we know SSH has its family of issues. It's an older project, so it's been through some battles. It supports 2 different protocols. So if my security team says, well, we have this advisory, SSH has these 2 protocols, the original version should be scrapped, right? We don't want it running in any of our platform. Make sure that all your systems use SSH v2 to avoid all of these known issues. In a perfect world, SSH v1 might have been completely phased out in the default configuration for your upstream software vendors, your operating system vendors. That doesn't always happen, and we want to take responsibility for our own platform, so we're going to check these anyway. So if we were going to look at this by hand or sort of in the old way, we want to identify the file locations, and check all of our systems. We have to figure out some kind of incantation. How are we going to fix this? I have my sshd_config file. I figured out where it lives on the 8 different versions of Linux that we're using. And now I need to decide, are they all similar enough that I can push out one new file to the whole fleet? Do I need to customize it for certain pieces and all these other crazy things? So are we going to check it first or just push a new one? And then what's the plan for our images? If I build a machine tomorrow after I've fixed 1,000 nodes in my fleet, I don't want to have to remember to fix node 1001 after it's been built. I want to be able to either, should I rebuild my image or have some kind of post-install remediation, and all of these things come into play. And you're likely, hopefully, using some kind of configuration management for some of this stuff. But of course, we run across folks that, like, if there's an emergency, they feel like it's too slow to go through the old process, and they just kind of hammer it in with a sledgehammer into their platform. But we want something that's going to be safe. So when you get a mandate from security, how often do you actually check stuff? A lot of the places we were talking to were only doing one big scan, maybe once a year, maybe twice a year. They were doing a big audit of whatever, and then they'd spend like 6 months remediating all of the red stuff. And you get like these massive fire drills for certain things. So years ago when I worked at AOL, these would come out, you'd get like some kind of security alert on whatever platform we were using, and you'd get a report out of the configuration management database about how many of your things you had that might match this component. And then somebody in the tools team would write a tool and dump out all of the bad ones, and then it'd be a race to the end of the week before you had the time to fix all of them and make sure that everything was going. And every day your manager would be pinging you on AOL Messenger at that time. Is it done? Are you done? Is it done? Are you done? Can we put this away? They're asking, is it done? That's irritating, right? It's super annoying. So instead, we use InSpec, right? So we'll fix all of these people things and the communication things, and we're going to wrap all of them up into this one tool. So if you want to find InSpec, it's at inspec.io. Everything I'm going to talk about and the rest of the talk is all open source. So it's all out there, freely available. And like I mentioned earlier, the spec is a hint of the things that we're going to see. So that sshd_config file that I was talking about earlier, right? I want this thing that I want to check these protocols to make sure that protocol 1 isn't being used and protocol 2 is the only one that's there. The good part about SSHD config is that it's pretty common, and it's also something that's commonly checked for security features, to the point where our InSpec engineering folks have actually built in an SSHD_config resource. So if you're familiar with Chef, it's the same sort of idea of resources across the two products, where the resource itself is sort of this atomic component that you can just sort of refer to, and the libraries underneath the tool will take care of doing all the hard work of finding that file, regardless of the platform, reading through it, parsing through the text that's in it, and checking for the things that you want to see. So SSHD config, I have the ability to determine how much impact this sort of thing has. When we're talking about scanning tools and security tools and even sort of metrics and monitoring and things that you care about to certain degrees, you have sort of things are warnings and maybe you don't care about, or you have things that really should be fixed right now or as soon as possible. And we've listed that as an impact on an InSpec project. So you have impact 1.0, meaning fix this thing ASAP. We give it a title and a description. So these components end up helping your maybe less technical or less hands-on technical compliance officers and those sorts of folks who don't necessarily need to know the nitty-gritty of the change in the file that you're checking, but they need to understand that this test is going to reflect the things that they asked you to do in their risk assessment or the documents that they're providing to you for your compliance or whatever. So you are able to do an awful lot of human-readable stuff inside the InSpec tests. And then finally, I'm digging around in the actual file, right? And it pulls out these characteristics for the things that I'm looking at. And in this case, it's a protocol, right? With protocol v1, v2, and all that stuff. You could also look for the other encryption things and the stuff that's in that category if you wanted to. And I'm just going to compare it to the value I want it to be. And it's that simple. I have now this test. I can use it on various kinds of Linux for my platform, and I can keep this and share it and use it as often as I need to. So our resources, InSpec includes a whole bunch of built-in resources for common services, system files, configurations. The up-to-date list is on the website. I think there were 45 the last time I looked. I'm sure there's more now. For things across different platforms that you might need. The built-in ones for Linux work on several platforms of Linux, and there's also stuff that would be specific to Windows, like registry keys and stuff like that you can also include. The resources have characteristics that you can verify for your requirements, and then a bunch of matchers that work with those characteristics. If you're familiar with, say, server spec, it's very similar to the way that tool behaves as well. So if I'm looking at, I've got my SSHD config, that's my resource in this particular example. So we hope, and sort of the driving force behind the resources, is takes that sort of grep for X out of all of your testing phase, as well as the figure out where on the file system I should be looking for this thing. And the parsers then are included in InSpec to do all that sort of work for you. And right, like I said earlier, mentioned earlier, the RSpec, and it's definitely meant to be human readable, so you can share these out with all those folks. So the language, the way it's constructed, is an it's, should sort of matching, and things like it should exist for files or other items on the file system, directories, those sorts of things, packages that maybe should be installed, services that should be enabled, but also more sophisticated things like max log file settings or exit status if you wanted to run a script, say you got from your upstream vendor to check a particular vulnerability, and your security folks say, hey, make sure you run this thing and make sure that it comes back clean. You could put one into an InSpec test, and the exit status could be 0. And also things like GID and UID and other system components. And it also has some other weird, complex built-ins based on stuff that we've needed, or the InSpec team has needed over the course of the development of the tool. Black magic, like limits.conf, is also included for the things that you can check or maybe need to have settings for, particularly in constrained environments there. So things like digging around in the domains for settings in limits.conf if you're still using things like FTP or other sources that use that. I find limits.conf completely insane, but that's just me. Running InSpec has a lot of capabilities that way. It is a command line. It is, for the most part, a rational command line, so the tools, the subcommands sort of fall out in a regular pattern. It installs as a Ruby gem, or you can bring it in as part of ChefDK, which also gets you Test Kitchen, which is part of that nice tool set there. You can run it locally, so I can test the machine that I'm currently running on with it, or I can execute it remotely against another machine via SSH or WinRM. So InSpec logs into the target and will run the tests for you. So in the difference from sort of, it's like in the Heisenberg uncertainty principles, right? Like if you've made a change to the target system, you're really testing its actual state. So what InSpec ends up doing is not permanently installing anything on the target system if you don't request it to. So if I'm running something and executing it remotely against the system, it's not actually porting new pieces onto that system. There's also a read eval print loop shell that comes with InSpec called the InSpec shell. And that's also super helpful if you're learning InSpec, figuring out in real time and all that kind of stuff on your tools. So what it kind of ends up looking like, you put an InSpec test in an RB file, and if you want to run it just locally, it's just InSpec exec. InSpec execute this file. If I want to run it against a remote Linux box, it's going to use SSH as its transport, and I just give it the same sort of incantation I would for regular SSH-I for my identity and all that kind of stuff. For WinRM, if you need to enable WinRM on your host, like Matt Rock is one of our Windows engineers, and every time I have to touch Windows, I have to refer to his blog on how to work with Windows. But enabling WinRM and all the magic that goes into there, he has a really nice post about, which is very helpful when you're working with InSpec. And finally, then you can actually get into running Docker containers to run these as well, if you'd like to look at that. So what it looks like when you run it, InSpec runs with fail tests return non-zero return codes. So if you're plugging this into a workflow or pipeline or something like that, it behaves in that sort of rational way that way. So if I have something that has nothing successful and a single failure, even if it has some successful stuff, if there's any failures, it's going to give you a non-return code. So when your tests pass, you get the good return code here. So 0 failures, and you get a 0. So it's super easy for plugging into other patterns that way. There's the additional parts for the documentation for Test Kitchen, if that's interesting to you as well. One of the more powerful components that sort of lives in the InSpec ecosystem is an idea we call profile. And profiles allow you to sort of gather up a whole bunch of tests and package them as one entity. So it gives you one place to say, for all of my web application layer things, here are the security and compliance requirements we have for those kinds of entities. For everything that lives in our Linux fleet, here are the sets of tests you should be running against a Linux box, and you package them up as a Linux profile. So you can have those and use them on a regular basis. So each profile can have multiple test files included, have the ability to sort of also publish custom resources with these profiles that come along in a library. Each test file generally looks for one required outcome, but it might have to look at different objects for in order to make sure it's meeting its requirements. One of the examples of that was the WannaCry thing that I showed earlier, is that on different platforms, it's looking for different knowledge base fixes, right? So different KB numbers on the Windows machine, and only hitting when at least one of those is okay. So you might have things that are digging around and looking at different components. It's also super flexible. You can create your own profiles for your specific software and the things that you need. If I want to start a new profile, it's super easy. InSpec init profile, it puts in all the skeletons, so I don't have to remember where files go, where other stuff lives, and things like that. And then if I want to run a whole profile, I can do a check to make sure the profile itself has good syntax, and then an InSpec exec, just like I did for the other RB file, for an entire profile. And it's going to go through and test everything that's in that profile. So we have our InSpec folks have put together sort of a mirrored pair of components with a cookbook, so chef cookbook called OS Hardening, and then a Linux baseline InSpec profile that ships with some of the sort of regularly recommended Linux hardening steps. So different settings for system components and services and things like that that are included in this. So when we run this thing, if I want to push this, I'm working in Test Kitchen, I have a new image maybe that there's been an update or whatever to my default image, and I want to make sure that everything's okay. I can put these in to work together. I have OS hardening, which is a thing that's going to make changes to the system to actually secure it and bring it in line. And then I have my Linux baseline profile, my InSpec tests in this section, to actually verify that I have passed all the tests that's required. If I want to look at these things, they're all open source. These components, as an example, are all out there. The OS hardening has a whole bunch of things for stuff like PAM and TTYs and sysctl and stuff like that. And the usual things you'd expect for sort of hardening up a sort of generic Linux install that you've sort of just gotten off a CD or from your provider. So out of the box, if I run this against a host that hasn't been hardened, right? I'm just looking for sort of these default things. I want a baseline. Maybe I don't have a security profile yet. I just want to see what's out there. I'll take this one and see what it looks like against my image. And it's telling me that of all the things that are in there, I have 25 things that were successful and 25 failures of particular objects. And then the individual tests, there were 77 that were successful and 39 that were failures. So obviously, what I have in my default image for, this happens to be CentOS 7.2, not meeting up with this sort of hardening thing that I've chosen to take a look at. When I run it with hardening, so I added the hardening recipe into the system, so that means I'm going to initialize the box, run the hardening scripts against it, which happen to be in Chef in this case, and then I'm going to test it with InSpec and see that they match up. So this is an interesting demo if you were looking at experimenting with InSpec to sort of take a look and see how the workflow goes and how the pieces fit together. So things that are in the Linux baseline profile, so they're all sort of divided up as categories for the things that are in there. So they have test names that reflect back into the source document that these were built from. And I forget which one they used for this because there's so freaking many. Oh my God. So things like checking owner permissions for etc shadow, I have my descriptions, and then I can test multiple things about this file that I'm looking at. And all of these things are probably requirements that were spelled out in that document. So the document probably has a page about etc shadow that has all of these discussion about how it should be set and how it needs to be used and on all of these things. And I can boil that down into a test that says, here's the things I need to match based on decoding all of this language in the security document. So over time, what we hope to do, and what folks have been doing with InSpec so far, we build a comprehensive set of checks for the systems that they run. There's a bunch of profiles that are already open source. The InSpec profile is actually part of our supermarket, so you can actually download some default ones, like the OS hardening one, and take a look at those. So you build up your set of checks. You run them anytime someone needs to make a change. So InSpec is very, very quick, and they are always making sure that it doesn't degrade in its performance, so that the goal being that you run this thing all the time and not just once a year because it takes too long. And you want to make it easy for everyone to use and read and sort of relate to for their requirements for their job. And what we don't want is this WannaCry continuing to pop up out of the haunted internet and saying, oh, you built a new image and you didn't remember to apply your patches, so check your things. So that's InSpec. The resources, the basic web page of InSpec is at inspec.io. We have a number of workshops and other components in our chef training GitHub that are free for everyone to use. There's a blog post on detecting WannaCry that uses the code that I showed earlier. If you haven't seen her talk, Annie Hedgepeth now works for one of our contractors. And she actually went through a process, almost 2 years ago, of sort of deciding to come into tech. She was an artist, a craftsperson before that, and her husband is a technologist, and she was looking at tools to learn to sort of get into technology, and she looked at InSpec, and she has this really nice set of blog posts about how she was coming from not really knowing a lot about technology and using InSpec and thinking about it in that way. So it's actually a really nice progression from a sort of an outside perspective for folks that aren't necessarily not super into security on a day-to-day basis, but really even not into technology. But the approachableness and the relatableness of InSpec and the way it's built was super good. And she's given that talk actually at Config Management Camp as well. There's another one, if you have looked at Dirty Cow earlier in the year, last year, there's a post on that. And then we have some new features that haven't been integrated back into this talk yet about future things of where InSpec is headed. And in addition to just looking at the infrastructure layer and your Linux stuff and what's in your sysctl and what's in your limits.conf and how's your SSH configured, what's in your registry keys and things like that, also looking at how your cloud implementations are built. So if I build a new image in the cloud, I want to make sure that my engineers, yes, they're allowed to launch their own images, but I have to make sure they're always using our preferred good image to use as the source for that. And there's facilities now in InSpec for talking to cloud providers, Azure and AWS to start, as well as VMware, to check for certain characteristics of those components so that for cloud native, you're looking at the things being built correctly in those environments, which is super helpful. I hope people will experiment with that and let us know other things that can be added there. InSpec itself has a channel in our community Slack, which if you're into InSpec, certainly join that, say hello, and let us know how it is. And if you do any work with it in the meantime, our community summit in London is in October, and we are soliciting talks and sort of customer and community experiences. And I'm happy to hear from anybody who is playing with InSpec and looking at that, how you're using it, and what you think of it for that. So I'm happy to take questions if we have time.
Hands up. I really want to throw this one.
How's the Jenkins integration nowadays? In the beginning, you could send computer-readable reports to a commercial product, but I'm in a Puppet environment, but I really want to have the integration with CI.
I'm not exactly sure. Like, I know that's something that folks have been looking at and working on. Adam Leff might actually know in particular where that is right now. I love those things.
You have these profiles. Oh, yeah. Okay, you have these profiles, but there are several supervisory bodies, like you mentioned HIPAA, there's DISA, there's NIST, and so on. And they have benchmarks or norms, and do you have these ready-made? Like, we can sort of run a Linux system and have it be compliant to the DISA stick norm that I just mentioned on Twitter?
Yes and no. So CIS... Yeah, so CIS are the ones that we started with, and they are part of the commercial components of InSpec, which I haven't talked about. Everything that is mentioned here has been the open source stuff. There's actually an older version of CIS I think it's the 2015 release of CIS. Was something that we had been experimenting with early on, and it is open source. But the current ones are part of the commercial stuff. And there's the hardening one that's on here. I forget where they derived that thing. It might be a SANS or something like that. And there's other folks that have been starting working on those in an open source fashion. On the commercial.
Is there a way to audit the work that has been spent on hardening with an objective source of the norms, like SCAP or OSCAP?
There's always the tools that they ship that you pay for if you're subscribing to those things. I haven't seen a full workflow for that, or what that ends up looking like with the combination of, say, InSpec plus the hardening scripts that you would use, either Chef or Puppet or whatever, and then the end audit tools that those things provide, the scripts or whatever that come, the Java nonsense thing that CIS provides, and how those all work out. I'm not sure our engineering has gone that far with it, but they may have. We could ask them that, definitely.
We got one more question.
Yeah. Hello. I'm currently using ServiceSpec to monitor, to test the environment which is set up by Ansible. And last year, on the last DevOps days here in Amsterdam, it was the first time that I heard of InSpec. And I thought it might not yet be ready back then because some of the migration seemed to be a bit awkward. But how do you think, how hard is the migration, and is it ready to replace ServiceSpec?
So it does a couple different things from ServiceSpec. The central server that InSpec provides is certainly a different component than what ServiceSpec does. From the things that I talked about today, ServiceSpec and InSpec are comparable, but not one-to-one. So they're each sort of, it's like you think of a Venn diagram, they're maybe 85% overlapped. And there's a few things still in ServiceSpec that we haven't ported to InSpec. And there's a growing number of things in InSpec that haven't been ported into InSpec or into ServiceSpec. So thinking of like one-to-one migrations, there's been a couple places where some of the language of the spec rules has changed for particular resources. It hasn't been a lot, but has probably been enough that you definitely want to take a look at them each individually, which might be a bit more overhead than you'd be looking for a full migration for those things.
Question for that? What about the E2E tests? I've had a look at Infotaser and thought about using ServiceSpec with Infotaser Gem to do some end-to-end testing. Is there something similar in InSpec?
Not yet. No, that'd be an interesting thing to look at as well. Yeah. Anything else?
All right, that's all the time we have right now. Annie's post is going to come up in a second on the Twitter wall, as soon as Twitter decides to not kill my mic and the Twitter wall. Thank you, Mandi. Great talk. Thank you for kicking off our second security session.